October 13th, 2022. So here we are in the East Shop, and this is our downdraft table, and it's not very effective with the way this is set up at pulling the dust and fine materials away from us, which is what it's designed to do, or supposed to be designed to do. So we're going to make some modifications on this fan here and change the airflow, and we're going to set it up so the fan is basically boxed. We'll be able to use the airflow coming up from between these two 2x4s in a channel. And also I'm going to put a duct in here so that when we're running the heat gun and the torch and that kind of stuff, we can actually put a duct right down over top of that and take the smoke and fumes away from that immediately and exhaust it out. So that's the plan. Additionally, we're going to try and tighten up the airflow in here so this place is a little bit warmer, because in the winter time it's basically outside temperatures with a little bit of wind protection. So we're going to tighten things up a bit this year, but thought I would do a precursory video of how this is currently set up, and then as I put it together, or when I finish it, I'll share another shot. Alright, that's it for now. One detail I wanted to point out on this is that we have this coil of wire. This was just rigged up, get it running kind of thing, directly in the way of the intake of the impeller, and that is greatly restricting our airflow capacity as well. So we're going to shorten that down in the process and get all that airflow restriction out of there as part of this upgrade. I guess while we're at it, we'll just take a look at the space here. It's a garage door on this side, so wind comes in there pretty hard. We put plastic up here last year. We're going to try and tighten this up more this year. On the other side of this space is also insulated. This tends to be where we come in and out in the winter. This also is very cold. I think the idea we're going to apply here is probably preheat the air either in this space or on some intake pipes here coming through the wall. And then we'll dump that preheated air out down lower here, probably around 2 or 3 foot off the ground, so that we're mixing warm air into the space. There's one problem we have here is we're pulling cold air in from outside, from the cracks around the windows and through here, and the only heat source we have here is this, which this heat pump is great if you're not moving air, but we need to be moving air for the job that we're doing to exhaust the fumes and the dust. So we need to preheat the air so we have warm air coming in, and that hopefully will tighten things up in here so we have a little more comfortable working space. And so that's part of why we're tightening the fans and that stuff down. So just thought I would give an overview for context. Okay, here we are. I made a few primary cuts to get our airflow control in place. Basically kind of box the fan in. I've got a blanket stuffed in the end for now over here, and I get this side blocked up with some plywood, and I got the paint and the contractor bags on top just to weight it down so that seam sits fairly tight. So the space that's in here between the plywood and the fan intake is 49 square inches. It's 1.5 inches by 33. And so to measure that, to weigh that against the throughput capacity of, say, a 6-inch tube, like the duct that I plan to add to this to come over and make it so we can pull smoke and fumes directly up off of a work area. To compare that, it's 49 square inches in here of the surface area where it's coming through, and a 6-inch pipe would be 28 square inches. So this is basically a little under double the air capacity of 2 6-inch pipes going through this flow table right now, and it's actually giving us pretty nice laminar flow now. I'll demonstrate here.
So now here the Cobra tends to make a little bit more smoke than the heat gun does, as the heat gun runs at about double the temperature. The heat gun runs at 1200 degrees, this runs around 600. So let's just take a look at what happens with the smoke now. Before, it would drift up and kind of go off into the room and you'd smell it. Now you'll see as it starts to smoke, it's being drawn right down in to the draft table, up to the fan, and exhausted. So now there's nothing making an escape in the form of smoke and fumes from the torching of the paint. And that's a big thing, because we do rail respirators here when we're working with these materials, but man, that respirator gets old. It's nice to be able to take it off and not be smelling any fumes or getting any fumes at all. So you can see that's working across the span of that whole thing perfectly. So that's what we were targeting. Now, in addition to that, we want to make sure that our flow in here streams in a similar fashion, so that as we're sanding, scraping, etc., there's always a laminar airflow headed toward the fan as an exhaust. And that's really comes down to is distributing laminar airflow from the fan of such a small size to such a wide area of table. I'm going to explore that a little bit more after we get the main part of this built. And then we'll see how the airflow works in here, and then we'll possibly modify if we need to a bit to get it to run a little bit more uniformly. But I think it's going to be pretty good overall. Anyway, just an update. That's where we're at. We got some basic forms here, and we got an idea of how the airflow actually works here using this fan in place, etc. I guess I should mention that right now the door is open on the space here, and same back there. So right now it's a little bit different than when it's closed up in the winter, but it gives us a good idea of what the volume capacity is. Alright, that's it for now. Alright, it's been a couple of hours of testing and figuring and fitting, but here's where we're at so far. And this is not fully evolved yet. This is just kind of to get an idea of how to really control airflow properly. Most of the time when we're torching or using the heat wand, it's up in here because this is the front of the bench, right? So this is where we're working really. Now, you look at that cigarette smoke there. You can see that's being drafted down in. Pretty nice. So, the airflow is decent. But look at this. Look how much space in surface area we had to remove in order to get that flow. So here's what I'm thinking. Because we work so many different jobs, we like to keep this table flexible and as big and open as possible, so that when we lay a window out on it like that, and it's bigger, we can fit that in our workspace. So that's why I try to keep this box as small as possible, but we had to make enough room to accept the fan and a little bit of airflow for the air to accelerate into the back of the fan. But now we have what I figured out. I chopped a few pieces of ply down to block out bigger surface areas. This is 1/2-inch ply. That dimension there is actually 3/4, so I would do this with 3/4 ply as the finished product. And I probably would stick 1 or 2 slats underneath that into the slots where these used to go to support it, so you have a nice solid base. And then I was fumbling around here, I realized I need to close off more area, but I don't want to close everything off at once. And So I was like, ah, actually these kind of fit, and they leave a little gap to let air flow through. So that's kind of nice. And then I was thinking, well, that works, but what we really want is something that doesn't trap the dust when we scrape, because we're scraping over the surface, and so all these flakes and dust and particles are falling off, and they're going to settle on the flat surface, right? Well, my thought was if we took a piece of molding, like a 45-degree flat piece of molding, or if you took a 3/4 by 3/4 strip and cut it at a 45, you'd have this 45-degree angle. And if you toe that in on each edge of these, now you got this steep surface for the dust to fall through between these. So that's my line of thinking at the moment on how to solve that equation a little bit better. We seem to be getting pretty good airflow. I haven't done the heat gun test on this yet. I'm about to do that shortly. But I just wanted to get it down to where, at least with the wand going, it takes the smoke. So I got the wand heated up here. So let me just give a quick demonstration of that. All right, here we go. We got a fresh piece here, fresh paint. You almost can't even see the smoke. It's being drafted directly down into the downdraft table, which is how these things are supposed to work. The problem is we have such a large open surface area like we do, you need to drain a tremendous amount of airflow to make any kind of velocity. Sorry about that. You have to have a tremendous amount of flow to make any kind of velocity, because the velocity of the airflow depends on the size of the hole that it's passing through. The larger the surface area of the hole that it's passing through, or tube, the more volume it can carry. And it's not quite as intuitive as you might expect. Hydraulics works the same way here. If you double the pipe size, you quadruple the volume of flow that can go through that pipe. So in this case, what we're trying to do is restrict the volume of flow of that fan down to a narrow area. Down to a narrow area, so that we can suck that smoke out. Because of the velocity of the airspeed, it will actually overcome the convective force of all the heat that would ordinarily make the smoke rise. There's enough airflow to overcome that, and that's what you're seeing here as I'm going along with the torch. I'm not getting any fumes in my face at all right now. I'm just coughing because it's been a long day. My throat's a little dry from talking loud over the fan. But anyway, so I just wanted to demonstrate this principle here. And you can see this is working pretty well. Well, now it's time to test the gun and see how the gun does. The gun is blowing, so that might be a little bit different scenario, but we'll see how it goes. Okay, so I tried the gun down here on a flat surface like this, where the airstream is hitting it and then deflecting off the edge, right? And that works fine. No fume smell coming back up, so that's awesome. And I just tried flipping the block out here over to here, because that's nice and simple to do now. And I did this section here with the gun over the line here, and that also no fumes, no smell. So that is working fantastic. I'm going to mess around with this a little bit more tomorrow before I do a final assembly, and I'm even debating whether I even add another tube up here for now. I might not. If this works for the torch and all that, and we can make it, you know, make it do what it's supposed to do, we might not even need to put the tube in. It would be nice to keep the overhead space and the light open as much as possible. But we'll see how it works. For now, primary semi-build and test is very functional and very effective. So that's a great result to close out this part of the project or end of the day with. So hope you found this interesting and informative so far. Don't worry, more to come. Alright, well, we're refining it down a bit. Did some thinking on it. Really want to keep most of these brackets in place. Didn't want to interfere with this surface too much, but wanted to be able to control and maintain the airflow. So this is what I came up with. Basically, we got hinged air gates that can drop out, so we can just let the air back here if we want, and then if we want we can pull the gates up and block the air off from back there, and that basically forces it all to come up into the front. I left a gap here. We'll see how the total airflow works when I get done boxing the fan up and doing some more testing. May add a piece of aluminum flashing here just to fill this gap if we're not getting quite enough airflow to the front. But I think that'll do it. May end up doing a bigger gate or maybe another 2 gates in the back, so we can drop the back out too, but I don't think that's as necessary as the front, since, like I said, most of our scraping, torching, etc. work is up in the front corner here. So this is what it's developed to so far, and I just wanted to show where we're at. I guess while I'm showing you, I'll just pop these rails off quick and show you. I basically just took, they're like the old door latches. Basically just took those, forwarded them to a 90-degree on the bracket, and then just drilled holes in so they can lock in, lock out. So that when we go to clean this out, so that's the other thing I had to take into consideration here. When we go to clean this out every so often, we need to be able to get in here easily and scoop this out and not have all kinds of stuff in the way. So I didn't want to put anything in the way here that was permanent. So these basically just drop right out. Bang. They pop out. You can do your clean out, and they pop back into the holes. Click, click, and you're back in business. So simple, straightforward, easy. I may get some pulleys or something, change this cable routing so that they come out over here or underneath here, kind of like a console for it. But for now, this is the simple testing method. So that's where we're at for now. Alright, so now we got the box closed up. Just 2x4 on each side, and I put like a 1x down the middle just to help close this seam up nice. Just working with some rough ply to start with. So the box will actually pop off right now and pop out. Eventually, probably just toenail that in, 1, 2 on each edge or something. But for now, that makes the airtight seal we need. Well, you know, relatively airtight. There we go. And I even made a little punch-through hole for the cord to come through. Alright, so now to refine the rest of this downdraft table quick. Alright, here's what we got so far. Fan box is all sealed up. Came over here, I added an extension on this drop gate here and a partial extension on this one. Reality, I didn't just have a piece long enough to fill this whole width out, but I also realized that it wouldn't hurt to have a little bit of open air gap on the edges more toward the front, so that way as smoke comes off of the gun and tends to curl around toward the edge of the table, there's a downdraft ready to suck it in from the edge. I may add another edge hole here and here for the same reason, just to have basically an inflow air channel on the edges, so that anytime smoke or dust drifts anywhere on the table, at the edge there's a negative pressure sucking it in. Anyway, these are set up so we can open this up for, like, if we're scraping back here or we're torching back here, we want the airflow back here, we can have it. It's real simple. We just drop that air gate down to the next latch point. We could dump it all the way open, but I don't want to block that airway too much. So rather than close all the way out to the ramp or close to it, we stay up above it. That leaves us a gap underneath, so our airflow continues underneath there from the front. This one, same thing, except this one we can just drop right down. Still getting airflow on the sides around that, but I also have a point for that as well. Then I was playing around with another piece in here just to restrict this a little more. I don't think that's necessarily. Anyway, so our air gates close up. Of course, if I'd stop screwing with things, it would stay. Bang, they close up. That pushes all of our airflow into the front here. And I'll demonstrate. Right, here we go. I'm using the wand for most of this testing because it puts out more smoke and tends to make a lot more stink and fumes when it's in use. But you can see that smoke is getting sucked right down the air channel. We got no fumes coming back up at us. So that's nice.
Ah, yes, a beautiful sunset.
So, we're going to call it good for now. I started to finish this video about an hour ago, and then I realized I had a few details I wanted to finish. Got the fan wired into a shorter length of wire here. We didn't need all that excess wire, so I rewired that. Left a little bit of slack because I think we're going to do something with the outlets over here that's a little more efficient too. Probably put a power strip here and a power strip there. And then each station's fan and light system can go on and off in one switch. You can see what this all looks like without all the wire wrapped around it and stuff. Definitely a high speed, high volume fan. And we got the box here. One sec. Alright, so that just pops in place right now. Fits pretty tight. You can hear a little bit of rattle there. There's a little bit of a gap. Probably toenail this in or something like that. You know, stick a couple of screws in each edge. But that's pretty tight. It gives us a good air pathway underneath there. Oh yeah, let me show you that air pathway that the air is flowing up to the fan through. Alright, so this ply edge locks into the channel here in the back. And so that basically just leaves this space here all the way across open. And like I said, that calculates out to about 49 square inches. So it's a decent volume space. Depending if we need more flow or I feel like that's still restricting flow, I may bump this out another 1.5 inches or so and open that channel up a little bit more for airflow, for inward airflow to the fan. But we'll see. And we may also add an overhead, like maybe a 4-inch or a 6-inch flexible pipe for when we're torching up on the brackets and stuff. But anyway, for now, this just pops in place, which makes it convenient for modifying, upgrading, etc. Figurines for later. And guess I'll just show these quick. So it's got drop out in here for extra, because I don't even think I really need that. If you look, You can see I'm holding that cigarette a good 6 inches off the deck there, and it's pulling that down. And that is because of these drop gates that I put in, so you can block off the airflow. Oops. So you can block off the airflow to the back part of the table and push it all up front. So when you're sanding and torching and that kind of stuff up in the front here, there's enough airflow to suck all that smoke, fumes, dust, and other toxins away. I think this is going to make for so much cleaner, so much nicer work environment, and I think it means I'll be able to take off the respirator a bit more for when I'm working in here, and that'll be nice. So then after this, we're going to upgrade the heating system, which we have a heat pump here that heats the space, sort of. But the airflow has been all wrong here. We're pulling cold air from all the cracks around, right? And we're not preheating that air. So then this is trying to spin the air in this room and heat it while we're pulling a huge volume of air out of the room. So you never really warm up in here like that. Only way you warm up is if you shut the exhaust fans off, and you can't do that if you're working on what we're working on. So we're going to put a couple of ducts here coming onto the intake side of this. This is the heat pump. The intake side of this is up here for airflow, and the outside is here. This opens up, and so we'll run two ducts over to here, and we'll pull them in through this wall here, so that the air is coming from inside this space, which theoretically will be a little bit warmer, and this wall, this inside wall, is uninsulated, so we'll just basically make this an air port to let the air in, and that way all the cold air that's coming in gets dumped directly into the heater intake, so it's heated on the way in. So we're heating the air as it comes in, and that way we're not trying to play catch up so hard. I think that'll make a huge difference. And then if we need to, we'll add a preheater on those ducts to bring the air up, say from 20 degrees outside or 10 degrees outside to even like 40 or 50, so the heater can compensate the rest of it easily. But we'll see how that all works out, and we'll have to upgrade this table here as well in the process of that to control our airflow a little bit better. But it should be good. One thing I may add on the outside of these, although these fans have louvers, I may just add some kind of a block plate we can throw on the front of this. So if one of us isn't here and that fan isn't in use, we can seal that nice and tight, and that'll keep cold air from coming in through the other person's fan who's not in operation. So, alright, I think that's pretty much the tour for now. This is where we're at for now. I'm going to test this for a couple of jobs, or at least a couple of frames, see how it functions and operates, see how well it works, look for any design flaws, tweaks that need to be done, whatever, and then we'll go from there. But for now, we'll call this the end of this part of the video, and look for more upcoming upgrades here at the East Shop of the White Clay Kiln Preservation. Thanks for watching the Pharmacy Seeds Network, and remember, keep your friends close and your farmers closer.